Alright, so as I said, I was going to talk about the mathematical definition of displacement. This is for everybody. This is not for IB or AP or for honors. Everybody needs to know the mathematical definition of displacement. Displacement turns out to be the change in position. That's the mathematical definition of displacement. It's equal to the change in position. Expressed simply, we can say that displacement is equal to the change in position. Oh, don't want to do that yet. Okay. So when we're talking about the change in, little bit of information here. This right here is a Greek letter. It's called a delta. In mathematics and physics, that delta, I don't know if it holds true for chemistry, that delta symbol is referring to the change in. You experience the change in a lot of things. So shorthand notation, we come up with a symbol that represents that change. And we choose delta. You know, to be honest, I don't know why we choose delta. That'd be a nice little trivia question. Why is delta chosen as the change in? But it's a little triangle with one side a little bit darker than the other one. Okay, that's a delta, and it's referring to the change in. Now, we can express this even a little bit further. We can refer to position. Position typically takes on as a numerical, as a mathematical thing. Position has symbols that are typically as X, Y, Z, or R. Okay? Those are our typical symbols for position. So if we want to take this one step further, we can say that the displacement is equal to the change in X, or the change in Y, or the change in Z, or the change in R. Okay? Or even if we want to talk about a two-dimensional or three-dimensional change in displacement, then we can say displacement. And I'm only going to talk about the two-dimensional model. Those of you who have enough mathematical background should be able to quickly see it as the change in X plus the change in Y. Okay? Remember that X's are independent of Y's. We don't add this change in X to the change in Y. We keep the plus in there because it's an important process that we got to keep track of. But this is displacement in two dimensions, the change in X plus the change in Y. Okay? Once again, I want to repeat this. We're not adding X's to Y's. We're just leaving it because if you remember from my notation, 10 meters X hat plus 10 meters Y hat. 10 meters X hat plus 10 meters Y hat. That's what that's referring to. Okay? We don't actually add those 10 meters to the other 10 meter. We don't do that because they're independent. Cool? Now, like I said, you can imagine what what three dimensions is going to look for. The R is a vector, typically referred to as a radius, that can be expressed in three dimensions. As a matter of fact, the three-dimensional component of that displacement is equal to R. The two-dimensional component can be expressed to R. We're talking about a circle compared to a sphere. That all can be related to R. So a lot of mathematical or a lot of physics tests that are a little texts that are a little more advanced will replace the X, the Y, and the Z with an R. Okay? And that's also when we talk about fields, gravitational fields, and talking about electrostatic fields, that it'll be under R instead of under X, under Z, under Y. Cool? So that's the mathematical definition of displacement. I'm going to take a few minutes and talk about how this is expressed. Okay? There's one more thing I forgot to say. Change in position, the way that we deal with change is going to be its final value minus initial value. Wonderful thing about doing recording it. Like, oh, I forgot to mention that. Position final minus position initial. It's referring to the change in position. Okay? So when we're talking about the change in position, change in velocity, the change in force, the change in whatever, it's the final minus the initial. Okay? Now I'm going to give you an example. Going back to this city block that's 10 meters in length, this is going to be his initial position, this is going to be the final position. Shorthand notation for initial and final is I and for initial and F for final. You also may say it as a not. So let me give you an example. Putting it under here, position final and the X would be something like that. Position initial would be something like that. Other notations that I've been known to use, which is equally as correct, is that X not typically refers to initial position, and then X simply refers to its final position. Just a little bit of notation. So here's his initial position, here's his final position. We're going to take the origin to be at his initial position. Okay. Grab my red marker so I can draw my origin. So his origin is basically right here at the corner of that block. So when we talk about the displacement of the object, I wanted to just look at it. Give me what the value is for his displacement. Well, his displacement is 10 meters in the x direction. But to do it mathematically, I need to keep track of both of his initial and his final position. So his initial position in this case, if I were to talk about it initially, is at the origin. Now, what if you remember back, if you don't, go back and look at the video for position, the origin is a point with the very specific values for both my x and my y. The origin is where the value for x is equal to 0 and the value for y is equal to 0. That is the origin. Okay? So if his position is at the origin, that means his initial position is going to be expressed as, and I'm going to write it directly under this initial position and think of it as a line. His initial position is 0 meters x hat plus 0 meters y hat. Okay? So that's his initial position. Okay? Now his final position is that he travels from here to here. He's moving entirely in the positive x direction, which means that he moves 10 meters, going back to that value, 10 meters in the x direction. So under his final position, I'm going to go 10 meters x hat, and how much does he go in the y direction? He goes 0 meters in the y direction. Okay? So that's the definition there. There's position final, there's position initial, there's a negative sign here. Position final minus position initial. Okay? Property of mathematics, this negative sign here gets distributed to both of those terms inside there. So what I'm left with is going to be, next line, 10 meters x hat plus 0 meters y hat minus 10 meters x hat minus 10 meters y hat. Adding my x's to my x's and my y's to my y's, I'm going to have 10 meters minus 0 meters, 10 meters. So I end up with 10 meters x hat. And then adding 0 meters to negative 0 meters, who cares? It's 0. I mean, it's 0 minus 0, 0 plus 0, 0 multiplied by 0, 0. So it turns out that these terms aren't even important. Well, they're important because they're 0. So his displacement is 10 meters in the x direction. What you told me initially. Okay? Cool? So he travels a total of 10 meters in that direction, in the x direction. That's his displacement. Okay? Mathematically, that's how we express it. Now, what I'm going to do is I'm going to answer that question next. I'm going to go ahead and stop this video. I'm going to start a new one that answers this question. How can I get a different value for position that I can for displacement? Okay?